So in Chapter 10, we'll take a look at a process called hypothesis testing. And in 10.1, we're going to approach some of the pieces to what would be a complete hypothesis test, along with some of the theory behind it. It won't be until we get into 10.2 that we really get to take a look at the entire process from start to finish. So we'll kind of piece together these things that we see in 10.1, along with some formulas and calculations in the actual sections regarding the different types of hypothesis tests that we can do. But start off the idea behind a hypothesis test. The word hypothesis says it's a statement regarding a characteristic of one or more populations. And in this sense, there's going to be this statement regarding a parameter, so something that describes the population. But there'll be a researcher or a group or a person that maybe has a belief or a theory that something is different, something has changed from a previously established or believed to be true value. So that's where the hypothesis testing comes in. So to start off with here in 10.1, very simple, just getting us ready for the three parameters that we'll be dealing with in the next three sections that we'll be doing hypothesis tests on. Just reading the statement, it says identify the parameter. I'm going to go one step further and even identify kind of the statement, the belief about the parameter. So here it says, in 2008, 62% of Americans, adults, regularly volunteer their time for charity work. A researcher believes that the percentage is different today. So the statistic here, or actually what we call the parameter, this 62% was the believed to be true value back in 2008. It's a value of a percentage, which is like a proportion. So we would call this the population proportion, is what the value was believed to be. And so we're saying now a researcher believes that percentage is different. So with this word different, that another way of thinking of that is to say it's not the same or not equal to. And so our statement that we would say this researcher is kind of promoting or suggesting is that the population parameter, which we use P for, does not equal, and then we would represent 62% as a decimal, 0.62. And so that's one type of statement. First of all, the parameter being the proportion, and it being not equal to a previously believed value. That would be one way to phrase that. Let's look at the next one. According to a study in 2006, the mean length of a phone call on a cell phone was 3.25 minutes. A researcher believes the mean length of call has increased since then. All right, so now we see the word mean a couple times, so it's pretty obvious we're talking about a population mean. So our symbol for that is mu. But the researcher believes the mean length has increased, which means they think the mean is now bigger, larger than, right? Greater than that 3.25. So that's a different kind of parameter, different kind of inequality symbol being used to describe the theory, right? The current possible scenario. The last one, using an old manufacturing process, the standard deviation of the amount of wine put in a bottle was 0.23 ounces. With new equipment, the quality control manager believes the standard deviation has decreased. So remember, standard deviation describes spread, so that would make sense that this is kind of the spread in the distribution of wine fills, but with a greater accuracy comes greater quality, which would mean we think we can decrease that deviation, that spread. So the population standard deviation symbol is that sigma symbol, but to be decreased means we now think it's less than the 0.23 it was previously known to be. So there are the three different types of parameters we're going to see through three sections, and also the three kinds of inequalities that we will be dealing with for a specific, again, person or researcher or group's hypothesis, what they think is actually the case. So hypothesis testing is a procedure that we use evidence to test these statements. And just kind of to very much generalize the process, we'll be making a statement, or there'll be a statement regarding some population parameter. There'll be a sample that gathers evidence, and then that information, that data, is used in a very specific way to assess whether or not we could say something has changed or something is different regarding the population proportion or the population parameter. So we start off with the idea that in these hypothesis tests, we will have two hypotheses. And we will always have the null hypotheses represented by this H with a subscript of a 0. You can call it H sub 0, or H naught is another scientific way to refer to a subscript of 0. But the null hypothesis, H sub 0, that's the statement to be tested, as in that's the original statement of no change, no effect, or no difference. Basically the previously believed to be true statement. The alternative statement is a statement you are trying to find evidence to support. So this is a statement made by the researcher or the group saying we think something has changed from when the last data was found or last statement was made. So we have a null and we have an alternative. And the alternative hypothesis is just H sub 1. So H sub 0 for null, H sub 1 for the alternative. And so with that, kind of going back to what we just saw on the previous page, there are 3 possible situations. You'll notice in all 3 situations, the null is that idea of the parameter being a certain value, equals, right? Parameter equals a certain number, whether it's population proportion, mean, or standard deviation. But then the alternative, there are 3 possibilities, like we just saw. You could have that the researcher believes the parameter, whatever it is, has changed in some way, so it's not the same, or has changed in specific ways, is smaller than or is larger than. Now, these create a picture for us to help us kind of organize how we're going to approach these hypothesis tests. You'll notice these names here of two-tailed, left-tailed, and right-tailed. The tails, in this sense, are essentially the idea that kind of visually describe where we think the actual value is. So for a two-tailed test, to pair that up with not equal to, the idea is that you don't know whether it's above or below, so you're going to allow yourself room on either end, that we would say the population parameter could be below or above. However, with the left-tail test, notice that corresponds to a less than statement. So we're saying that we believe the actual parameter is somewhere down there, somewhere much further below the center where it would actually have currently believed to have been. And then with the right-tail test for the greater than, same idea, the right tail kind of showing that's where we would expect the value to be. So notice the alternative hypothesis always tells you the tail for your distribution test. Not equal is both sides, less than is left, and greater than is right. The null hypothesis is always the statement of equals, again, what it is currently believed or was currently shown to be. And so that's the idea. The null hypothesis is, again, that idea of no difference, status quo. And we're looking for evidence to support that alternative hypothesis that was proposed. So next 3 examples, just kind of put that all together. Back to what we looked at initially. Full statements though now, full declaration of the hypotheses. We're going to determine the null and alternative and then state which type of tail test it is. So again, this one was a 62% and the researcher believing the percentage is different. So with the null and, if I ever do that, if I ever put an A there, that's because that's the other stats way of denoting that. That should be an H sub 1. We're dealing with a percentage, which is a proportion, and it was believed to be 0.62, but this researcher believes it's different today. So again, the null is always equal. The alternative is whatever describes the proposed comparison to that number. In this case, different, not equal to. And as we saw on the previous page, that would mean that to set this up, we would be dealing with a two-tail test. For the next one, the mean length of the phone call being 3.25, and the researcher feeling like it has increased. So for the null and alternative, we know we're talking about mu, originally believed to be 3.25, but now we want to see if we can find evidence to support that has increased. So it is now greater than that 3.25. And the last one, we were looking at standard deviation. So we use sigma. It was originally believed to be 0.23, but with the new equipment, we're thinking that the standard deviation has decreased. So we would be looking to support that statement there.